now we'll test our function graphs for line symmetry. So for dealing with line symmetry, the simplest way for us to kind of tell if something is symmetric across a line is to basically take the graph and fold it in half along a line of symmetry and see if the two halves match up exactly. And so if you went up to the previous problem like we saw before, you could see that if we folded that graph down the y-axis, we would have line symmetry across the y-axis. So that's a good visual example of line symmetry. Now, we do have mathematical tests that we can run on any given function or equation that will help us determine if there is line symmetry or not. Now, with any line symmetry, it depends on what line that the graph is symmetric across. And of course, we have four common lines. We have the x-axis and the y-axis, but we also have the diagonal line y equals to x and the negative sloping diagonal y equals to negative x. And so we have four possible axis asymmetries or lines asymmetries, and we have four different tests accordingly. Now you can see the mathematical definition and test in the table, and we'll use that in sample problem 2. So we're basically going to use a and b as a substituted value for our x's and our y's. And so let's take a look at sample problem number 2. So in sample problem number 2, we're given this equation ax equals -2, and we want to check for line symmetry with respect to the given axis. And so what I'm going to do here is I'm going to do the test by substituting a and b where appropriate for the x and the y. So we'll start our first test testing the x-axis for a line of symmetry. And so if we look at our table above, we're going to actually use the test and we're going to substitute the ordered pair a and -b, and for x and y. And so what we would get here is we would get a times -b in place of x and y equals to -2. And so then if we multiply this together, we get -ab equals -2. And then we're going to get ab equals to 2, which does not equal to ab equals -2. So we could say that this is not equivalent to ab equals -2, which is what it would be if we substituted the values for x, y. Now, that being the case, that tells me that this graph is not symmetric over the x-axis. So we'll move on and test the next value. So now we're going to test the y-axis, and on the y-axis we're going to substitute -a and a +b in place of x and y. So I'm going to have -a times b equals -2, which again gives me -ab equals -2, and ab equals to 2. Again, not equivalent to ab equals -2. So this is not symmetric along the y-axis. So now we go to our diagonal lines, y equals x. For y equals x, we're going to substitute x and y with the kind of a reversal of the values. We're going to now do b and a in that order. So I have b times a equals -2, and of course that just gives me ab equals -2. Now this is equivalent to ab equals -2, so this is symmetric along y equals x because it is equivalent to our given equation. So let's check equivalency across the other diagonal. So again, this time we're going to substitute for our test -b and -a. So we have -b times -a equals -2. It's going to give me ab equals -2, and that is also equivalent. And so that's going to tell us that it's also a symmetric across that diagonal. So this actually has two lines of symmetry. And the way we can quickly tell that, if we go back up here it says to check visually by graphing when finished with the test. And of course, if I wanted to graph this, I would have to convert my equation to something that is graphable. So I have to have y equals, so I'm going to say negative 2 over x. And so if I go here, you can see I've graphed f of x equals negative 2 over x, and I get these blue graphs. Now, I've gone ahead and graphed y equals x and y equals negative x, and you can see the symmetry across both of those lines. So we can visually tell when something's symmetric across a line, and then of course we have our mathematical method of determining that as well. Okay, so that is the wraps up line symmetry.